Hi everyone, my name is Suram and I welcome you all to my YouTube channel. Today in this video we are going to discuss about the chapter sound that is related to 7th standard. And sound, as you are knowing, it is a form of energy which excites in us the sensation of hearing. Sound is a form of energy which excites in us the sensation of hearing. So we will discuss in this chapter how the sound is produced and how it propagates from one place to another place, and what are the uses of sound in our day-to-day life. So sources of sound we are going to discuss in this chapter, and how the sound propagate, that is the propagation of sound. Propagate means how it travels from one place to another place. And last we discuss about the absorption and refraction of sound from the various sources. So very first, the sources of sound. There are the different kinds of sources of sound, the sound that we are receiving. In the human being, the sound is produced because of the vibration in the vocal cord. So sound is always produced because of the vibration. All the vibrating bodies are producing the sound. So vibrations, what are the vibrations? It is a rapid back and forth movement, forward and backward movement of any object or particle. So the human voice, how the human voice is produced, that I have told you, that is, it is produced because of the vibration and the vocal cord. This you people might have felt that whenever we are speaking, if you put your hand on the neck here, on the throat, you can feel the vibration on your fingers. Is it? So this vibration is produced in the vocal cord. So this is producing this human voice. So sound in the human voice is produced due to the vibrating vocal cord when the air from the lungs passes through the larynx. So the voice produced by the woman is shriller than the man, because women have the shorter vocal cord and then the man. So if short vocal cord produce the shriller sound and the large vocal cord will produce the dull sound, you can say. So how the sound travel, that we are going to discuss now. How the sound travel, that is the propagation of sound. How the sound travel, sound can travel in all the three states of matter, the solid, liquid and gases. So we'll discuss about how the sound travel in air. Sound travel in air like in the forms of compression and rarefactions. So molecules of air just vibrate at their mean position and it get transferred from one place to another place. Means from the speaker, the sound reaches to us in the form of compression and rarefaction. So what is the compression and what is the rarefaction? Compression is the region of where the particles are closer. You can see in the diagram the particles where it is closer, that is called the compression. Where it is some at a distance, that is called the rarefaction. So it travels in the form of compression and rarefaction. This is how it goes from one place to another place. Then what is the waves? A wave is a disturbance or the vibration that travels from a medium or in the space. So there are two types of waves, transverse waves and longitudinal waves. So we will discuss the transverse wave first. Transverse wave is what? When the particles of the medium vibrate perpendicular to the direction of wave, then the wave formed is transverse wave. For example, the ripples on the surface of water in the pool, you might have seen it is going up and down. That is perpendicular to the propagation of ripples. Ripples are going outward. Is it? From the center it is going outward and water is going up and down. Is it? Means it is perpendicular. As you can see here, it is in the diagram here, the ripples are going up and down. Is it? And it is going, the direction of wave is on this side, right side, from left to right, and it is going up and down, that is perpendicular. If the particles of the medium vibrate perpendicular to the direction of wave, is it? Wave is going to left to right and particles are vibrating up and down. Is it? That is perpendicular. So in the transverse wave, the particle of the medium vibrate perpendicular to the direction of wave. Is it? So this kind of wave is called the transverse wave. So it is formed in the ripples of the surface of water. Then second type is the longitudinal wave. When the particles of the medium vibrate along the direction of the wave, then the waveform is the longitudinal wave. So it is travel in the form of compression and rarefaction. The compression and rarefaction I have told you already, where the particles are closer, that is called the compression, and where they are at a distance, then it is called the rarefaction. There you can see here it is compression written here, rarefaction, compression, rarefaction. There is alternate zones of compression and rarefactions. So this is how the longitudinal wave forms. So sound travels, sound produced by the drum in the air, it travels in the form of compression and rarefaction. So this is how the vibrating drum is producing the sound, and the vibrate particles, air particles travel in the form of compression and rarefaction, and it reaches to the ear. So sound always need a medium to travel. Sound cannot travel in vacuum. Vacuum, you're knowing, it is the absence of air. Means without any material medium, the sound cannot travel. Sound always required a medium to travel. So speed of sound in air is 340 meter per second. It travels with 340 meter per second. So here is one experiment to show that the sound always need a medium to travel. In the first case, you can see we can have a well jar experiment. Bell jar experiment, we have a jar which is having the bell fixed inside it, and the connection is given outside to this bell, and there is lower bottom, there is a vacuum pump is attached with this jar. So in first case, when the air is present inside the jar, then we can hear the sound of the bell. Is it in the first case? And when the air is removed gradually, slowly, if we turn on the vacuum pump, then the air starts coming out of the bell jar. Then less air is left inside the jar, and we can hear the less sound, means a feeble sound we are able to hear. So when completely, in the last case, when the completely air is removed from this jar, you can see there will not be able to hear the sound. Then in the last case, we will not be able to hear the sound of the bell. This is the reason, because the air from inside the jar has removed, and it is completely vacuum inside it, right? So this shows that the sound required a medium to travel. Is it? It was the air inside the jar that can making the sound to travel. Is it? So if the air is removed, then we will not be able to hear the sound. So this shows the sound always required a medium to travel. Then sound can travel in all the three states of matter: solid, liquid, and gas. So sound travel faster in the liquids and solids than through air. So its speed is about 1500 meter per second in water and 5000 meter per second in steel. So means it is fastest in the solids, then in the liquids, and last in the gases. Gases, it, as we have seen, in the air it travels with the 340 meter per second, and in liquid it travels with 1500 meter per second in water, and in solids, in steel, it travels with 5000 meter per second. So it is maximum in solids. So speed of sound in a medium depend on the density of the medium. Is it? So density of the solid, as you know, it is more than liquid and gas. So sound can be reflected as the light fall on the surface, it gets reflected towards our eyes. We are able to see that object that we are discussing in light chapter. So absorption and reflection of sound, that is the last topic in this chapter. Sound get reflected from the surface as same as the light get reflected. Is it? So a reflected sound is given a special name that are called the echoes. So the reflected sound are called the echoes. So what are the conditions that are required for the echoes? Means all the sounds are not called the echoes. It is if the echo reaches to us within 1/15th of a second, then we can say it is echo. Is it? The distance between the listener and the source of sound must be 17 meter to hear the echo. Is it? And the intensity of sound should be sufficient so that it reaches to the listener after the reflection. The intensity of sound must be sufficient so that it reaches back to the listener after reflection. So these are some conditions. Then we have a device that is called the sonar. Sonar is the sound navigation and ranging. SO for sonar, sound, SO for sound, and N navigation, and R is the ranging. Sound navigation and ranging. So it is used particularly in the ships. In the ship it is used, and a signal is sent downward and it is received back by the receiver. Transmitter is sending the signal and transducer is receiving the signal back. And how much time has the signal has taken to return back from the lower surface or from the seabed, that time can be measured by using this transducer, and we can calculate the distance of the seabed, is it, or any obstacle is there in between the path, then we can calculate by using this sonar device. So it helps especially the navy person to check that whether there is any submarine of any enemy or any icebergs is there in the sea. That can be checked by using this sonar. So this is the sonar. It sends the high frequency sound vibration called the ultrasonic vibrations into the water, and the time taken by the vibrations to return back is used to calculate the distance of the reflecting surface. As we are knowing the speed of sound in the water, that is 1500 meter per second, and if we are knowing the time, then we can calculate the distance. Then what are the uses of echoes? Medical uses of medical applications of this echoes. Ultrasonic vibrations are used to get the pictures of internal organs. The technique used is generally called the ultrasonography. Ultrasonography is a technique that is used to get the pictures of our internal organs like kidney, liver. If we are having some stones inside the kidney, that we are going through the ultrasound. Then in case of heart, the term uses echocardiography. To get the internal pictures of our heart, we are using the term echocardiography. So here again the ultrasonic vibrations are used. So these are some medical applications or medical uses of echoes. Then echoes in nature. Bats emit ultrasonic vibrations and judge the distance of a prey by the time it takes echo to return. So it is a God gift to them that they are sending the ultrasonic vibrations in the air. So how much time it is taken to return back, so by that they can take the idea that where is any obstacle or there is any prey. So dolphins, whales and seas also uses these echoes to find the obstacles inside the sea as well as their prey inside the sea. So these are the echoes in the nature. Then we have the sound insulation. Sound insulation or soundproofing, it refers to the cutting the unwanted sound. Is it? To cut the unwanted sound, that is called the sound insulation or soundproofing. So the repeated reflection of sound is called the reverberation, and reverberations is quite different from echoes. Is it? Echoes is there is some conditions to hear the echoes, but reverberations are just the repeated reflection of sound. This you might have seen sometime in the auditorium. If you are speaking a big building, then we are able to hear the continuous sound, the repeated sound. That is called the reverberation. So in the recording studios, auditorium, theaters, etc., walls and ceiling have the double layer materials. Walls are a special material that absorb the sound, and the floor is also carpeted because there should not be any reflection of sound. Is it? To avoid the reflection of sound, there is some special material is there in the recording studio, in the auditoriums. So that is actually called the sound insulation. So this was all about this chapter. So next time we'll discuss about the question answers and the numericals. Thank you.